Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we are going to see about Electrocardiograph Ecg. It is a biomedical instrument which records the electrical signals in our heart. This Ecg test is used to detect heart disease, heart attack, and enlarged heart or abnormal heart rhythms that may cause heart failure. Sensors attached to the skin detect the electrical signals produced by our heart each time it beats. This electrocardiogram ECG represents the electrical activity of heart muscle, myocardium, graphically in the form of time-varying voltage. The amplitude of ECG graph is in the range of 0.5 millivolt to 1 millivolt for heart rate between 60 beats per minute and 100 beats per minute. In ECG test, usually 12 small sticky sensors called electrodes or leads are attached to the patient's arms, legs and chest. These leads are connected to an ECG machine by wires. ECG waveform of a healthy person is shown in the figure. A normal ECG waveform contains waves. Waves are nothing but positive or negative deflection from baseline that indicates a specific electrical event. The three main components of the ECG waveform are P wave, which represents arterial depolarization, Qrs complex, which represents ventricular depolarization, and T wave, which represents ventricular repolarization. U wave is any unknown wave, and this wave is very rare. From the figure, we can observe that R wave has maximum amplitude and Q wave has minimum amplitude. We will see in detail about each wave. First, P wave. It is the first positive deflection on the ECG waveform and it represents arterial depolarization. The normal duration of P wave is less than 120 millisecond and its frequency is 8 to 10 Hz. This P wave occurs when the sinus node, that is sinoarterial node, creates an action potential that depolarizes the arteria. The amplitude of P wave generally ranges from 0.5 to 2.5 millimeter. Arterial enlargements, usually due to pulmonary hypertension, can widen this P wave and increase its amplitude. The flat line from the end of the P wave to the starting of Qrs complex is called PR segment, and this reflects the slow impulse conduction to the atrioventricular node. Next is the Qrs complex. The combination of three waves, Q wave, R wave and S wave, is called Qrs complex. These three waves occur in rapid succession and it represents the electrical impulse as it spreads through the ventricles and indicates ventricular depolarization. The duration of the Qrs complex ranges from 60 to 120 millisecond. Its frequency is 10 to 40 Hz and the amplitude of this complex ranges from 5 to 30 millimeter. This Qrs complex is actually a reflection of left ventricular depolarization because the electrical vector generated by the left ventricle is many times larger than that generated by right ventricle. The amplitude of Qrs complex in patients with heart failure decrease or increase depending upon the phase of their illness, whether it is poorly or well compensated. Generally, the amplitude of Qrs complex increases due to the presence of left ventricular hypertrophy. High left ventricular voltage can be found normally in patients less than 40 to 45 years of age, particularly slim or athletic individuals. High frequency analysis of the Qrs complex may be useful for detection of coronary artery disease during an exercise stress test. The decrease in the amplitude of Qrs complex, that is less than 5 mm, may be due to damping of the electrical signal due to excess air, fluid or fat. If it is due to excess hair, emphysema or COPD. Emphysema is nothing but it is a type of lung disease. COPD is chronic obstructive pulmonary disease. It is also a type of lung disease which makes the lung hard to breathe and get worse over time. Next, damping of electrical signal may also occur due to fluid, that is pericardial effusion, pericardial constriction, pleural effusion, and edema. Edema is nothing but swelling of our body due to fluid retention, and also due to fat, obesity or amyloid cardiomyopathy. Next, T wave. T wave occurs after the Qrs complex and it represents ventricular repolarization. Usually, the duration of T wave ranges from 100 to 250 milliseconds and its frequency is 5 to 8 Hz. The amplitude of a normal T wave is generally less than 5 mm. Tall and narrow T waves indicate hyperkalemia. Hyperkalemia is nothing but high level of potassium in our blood, and hyperacute ischemic changes. Ischemic is nothing but restriction in blood supply to any tissues or organs of our body, causing shortage of oxygen that is needed for cellular metabolism. Inverted T waves represent myocardial ischemia. Next, U wave. U wave is an occasionally seen small 0.5 mm positive deflection wave which occurs after the T wave, and it represents repolarization of Purkinje fibers. Its amplitude is generally 1/4 of the T wave's amplitude. Large U wave is generally due to hypokalemia. Next, let us see the previous year's questions. First question, in a normal ECG waveform, which wave has the maximum amplitude? This question was asked in December 2014. P wave, R wave, Q wave, T wave. As we already know, R wave has maximum amplitude. So option B is correct. Next question. This question was asked in July 2016. Electrocardiograph is a graphical representation of electrical activity of heart muscle myocardium in the form of option A time varying voltage, option B a time varying current, option C a time varying pressure, option D a time varying blood concentration. We know that ECG is graphical representation of electrical activity of heart in the form of a time varying voltage. So option A is correct. Next question. This question was also asked in July 2016. The amplitude of an electrocardiograph signal is usually of the order of option A 0.001 millivolt, option B 1 millivolt, option C 10 millivolt, option D 20 millivolt. We know that the amplitude of ECG waveform is 1 millivolt. So option B is correct. Next question. This question was asked in Jan 2017. Read the following statements regarding biomedical instrumentations. Sphygmos is used for blood pressure measurement. EMG represents a record of electrical activity of brain. ERG represents the record of potential from the retina. ECG represents the record of electrical activity of brain. Here, if you see, A. Sphygmos is used for blood pressure measurement, and C. ERG represents the record of potential from the retina are correct. So option C is the correct one. Next question. This question was also asked in Jan 2017. ECG represents A. The rhythmic curve of depolarization and repolarization of the myocardium, the heart muscle. B. The waveform of the voltage produced in the heart muscle due to an externally applied electrical stimulus. Option C. The record of electrical currents flowing in the cardiac muscle. Option D. The record of intensity of heart sounds at different intervals sensed by an electroacoustic sensor. Here, as we all know, ECG represents the rhythmic curve of depolarization and repolarization of the myocardium, the heart muscle. So option A is correct. Thanks for watching the video. For more videos, don't forget to subscribe our channel.